Hello friends, welcome to the lecture series on engineering graphics, and we are learning at present cycloidal curves. So in the previous session we have seen how to construct the cycloid curve in AutoCAD. Now in this session we will learn how to construct the epicycloid curve. For that we'll go to the problem statement, construct the epicycloid curve. So for that the given data is small r is 25, capital R is 60 mm, and then we need to draw the curve traced out by the point P on the circumference of circle for one complete revolution. And afterwards we need to draw the tangent and normal at a distance of 95 mm from the center of fixed circle. So now let us move to the demonstration in AutoCAD. So first of all I'll write down the given data making use of mtext command. So the radius of a rolling circle small r is 25 mm. Then radius of the bigger circle, fixed circle or the directing circle, which we designate by capital R, this is 60 mm, and the number of revolutions is given as 1. Now similar to the cycloid curve, we know that in the case of cycloid curve, the smaller circle, that is the rolling circle, rolls on a fixed straight line, and during this movement it covers a distance equal to 2 pi r, which is circumferential length. Now here for this problem statement, the smaller circle is rolling on a bigger circle. The smaller circle is rolling on a bigger circle. So what we need to do is we need to find out the angle value which has been covered. So in order to do that, we need to do a small calculation. So we have seen in the previous session how to find out that. The formula is theta is equal to 360 degrees into small r by capital R. So you can type calculator, 360 into small r is 25 divided by capital R, which is 60. So the angle value is 150 degrees. So here I'll write down angle covered in one revolution is equal to 150 degrees. So how we have arrived at this 150 degrees is theta is equal to 360 degrees into small r by capital R. Small r is 25 mm, capital R is 60 mm. Now we will be seeing the case of epicycloid. In the case of epicycloid, the smaller circle rolls on another circle but outside it. Whereas in the case of hypocycloid, the smaller circle, that is the rolling circle, rolls inside it. So we are now learning the construction procedure of epicycloid curve. And to do that, first we will try to draw the bigger circle, and we know the angle is 150 degrees. So what we do is, now we are going to this arc option in the ribbon bar, and you can see the last but one option here is center start angle. Click on this center start angle. Define the center point, then type the radius value, which is 60 mm. We are drawing the bigger circle, so radius is 60. So type 60, press tab, and now you can type the angle value, which is 150 degrees. So this is how we got the bigger circle showing the 150 degrees angular value. So if you feel like it is slightly tilted on the other side, you can just make use of rotate command and make it straight. See, rotate, select this, press enter, pick a base point, and then you can just move the mouse so that it becomes in vertical alignment. Now we need to draw the circle, smaller circle also. So for that, I'll slightly move this bigger circle on the right side. Go to OSNAP, make center option on, move the cursor onto this arc. You can see the center of this arc is located. Now draw one line over here up to the start of the arc. Similarly, draw another line which starts from the center of the arc and goes up to the end of the arc. So make this ortho on. You can check the angle of this line. So you can see it is 14 degrees. So 14 degrees means 180 minus 14. It is nothing but 166. So you can set the angle at 166 and type 25 mm. So what we have done is, now we have drawn a line which is perfectly aligning with this. Then make use of circle command, pick this point as the center and the end point of the line as the radius, which is nothing but 25 mm. So now we got the smaller circle and we got the bigger circle also. Then we can make use of array command, select this line, press enter, go with the polar option, pick the center point of the circle as the center point. By default it will create 6 items. Click on items, type 8. So we have divided the circle into 8 parts. So the procedure is almost same, only difference is in the previous case we had a straight line. Now here instead of straight line we have an arc. So we have divided the circle into 8 number of parts. So same number of parts we need to make on this bigger circle or bigger arc. So you can make use of the divide command, pick this arc, type 8, you get these points. Now join these points with the center point of the arc or circle. So make node as on so that we'll be able to pick these division points. So join this first node point with the center of the directing circle and repeat this procedure. So we have divided the smaller circle into 8 parts, similarly the bigger one into 8 parts. The next step is, through each one of these division points on the circle, we need to draw parallel arcs or concentric arcs. So how to do that? Either you can make use of arc command or you can make use of offset command. So I'll make use of offset command because that is easier. So type O and press enter, go to through option, click on this through, select this arc and place it at the division point 1. Similarly, select this arc, place it at this division point, select the arc, place it at the next division point, select the arc and place it at this next division point. Similarly, you can do it for the locus of center also. So this line is the locus of center. I'll just change the color. So this yellow color line is basically the locus of center. I'll make use of extend command so that we extend this line up to the last division. Now on this locus of center, we need to obtain the new center point C1, C2, C3 and so on. So make use of extend command and extend the lines which are starting from the center of directing circle and passing through point number 1 dash, 2 dash and so on. So extend them up to the locus of center. So wherever these lines are meeting the locus of center, they are basically the new center point C1, C2 and C3, so on. Next, we assume that the circle starts rolling, and that rolling action we consider it by division distance. So in the first instance, we'll assume that the circle rolls by a distance equal to 1 division. And when it happens, this center C will now move to C1. So I'll make use of copy command, select the circle, press enter, pick the center point of the circle as the base point and place it at C1. So we are following the same procedure as that of cycloid curve. There is no difference. There we did it on linear lines, and now here we are doing it on arcs. So we can now see the circle is intersecting the locus of division point 1 at this location. This is the point, and this is basically the point on epicycloid curve. So we need to show this arc. So for that, I'll make use of break command. Select the bottom side and then move towards the upside. I'll repeat break. So you got the arc. Now repeat the same procedure for remaining points. That means we assume that now from C1 center, the circle travels by one more division distance. So the now center C will move to center C2. Similarly, this point P, which is on locus of 1, now it will move to the locus of 2. So in order to find out that, we'll select the circle, press enter, pick the center point of circle and place it on C2. So the circle and the locus of 2, they are meeting at this position. So this will be our second point on epicycloid curve. So in order to find out that, we'll make use of the break command, pick the downside and move towards up. So we got the second arc. Repeat the same procedure for the third one. Copy the circle, press enter, pick the center point of circle and place it on locus of center and third division. So the circle and the locus of third division point, they are meeting here. So this is our third point on epicycloid curve. Make use of break command, pick the downside and move towards up. So we got 3 points, and we already seen that at half the distance, point P, which is at the bottom, will obviously move to the top. So the fourth or the halfway distance point, it should always be projected directly without any construction. So make use of extend command and extend this line up to the top. So this point is nothing but our fourth point on the epicycloid curve. Now for the remaining ones, you can simply make use of the mirror command. Pick this arc, second arc, third arc, press enter. Define the endpoints of the mirror line. So this mirror line is nothing but your fourth division line. Select both the points, erase source objects, pick no, and you can see we have got the arcs on the other side also. Now make use of spline command and start picking these intersection points. So start with this point P, then first point P1, second point P2, third point P3, then P4, P5, P6, P7, P8, and once we have done, you can go to the end tangency. You can click on this end tangency, move the cursor to check the shape. Wherever you see that the shape is correct, click on screen. Now I'll select this epicycloid curve, right click, properties, I'll change the color, I'll change the line weight. So this is how we construct the epicycloid curve. Now we want to draw the tangent and normal, and for that the data is given as, I'll just refer to the slide, 95 mm from the center of fixed circle. So you can draw arc, define center of the directing circle as a center point, arc center option. The radius is how much? 95 mm. So type 95, press tab and draw an arc such that it cuts the epicycloid curve. So I'll just change the color of this arc for better visibility. So I just given green color to this. So you can see this green color arc, it is cutting epicycloid at 2 locations. So you can pick either the left side or the right side one. It is always preferred to go for the right side one. So this is the point X where we want to draw the tangent and normal. So now this is the X point, and similar to the cycloid curve, from this X point we need to now draw an arc of radius equal to radius of rolling circle, which is 25 mm. So arc command, center option, pick this point X as the center, type radius 25 mm, tab key, and draw an arc on the locus of center. So this is the arc. Next, what we need to do is join this intersection point of arc with the locus of center with that of center of directing circle. So make use of line command, pick the intersection of arc and locus of center, and draw a line up to the center of directing circle. So we got this line. Now wherever this line is cutting the directing circle, this is your point N. So join N with X and extend. So I'm joining this point N with X and you can extend. So this line is the required normal, and a line perpendicular to this will be the tangent. So again I'll go to the OSNAP settings, make all the OSNAP features off except perpendicular. Go to the line command, move the cursor over to this line, click anywhere and draw a line. So this is the perpendicular line, but its position is not correct. Again go back to OSNAP settings, make endpoint on, intersection on, make use of move command, select the line, press enter, pick this as the base point and place it at this point X. So this is the half tangent. You can extend it on the other side in order to obtain the tangent to the epicycloid curve. Now select these two lines, change the color, apply the line weight. So this is how we get the tangent and normal to the curve. So I hope you have understood the procedure. I haven't shown any of the divisions, numbering, lettering and dimension that is clearly shown in the previous cycloid problem, but I have tried to demonstrate the procedure of constructing the epicycloid and tangent and normal to it in AutoCAD software. The remaining part of dimensioning, numbering, lettering, that I hope you will be able to do it. Now what I want you is to adopt the same procedure as that of epicycloid solution and achieve the hypocycloid curve. The only difference that will be there is the circle that we have drawn outside the bigger circle needs to be drawn inside it, and we need to follow the similar procedure in order to obtain the hypocycloid curve. So I hope you will be able to do that. So with that we come to the conclusion of this session. Thank you.
Like, share, comment and subscribe VNR Digital Learning Resource YouTube channel.